Today, AI models are used in fraud detection, courtrooms, and hospitals throughout the country, and are becoming ever more commonplace. We encounter AI on a daily basis, from the search engines we type into to the smart home assistants we interact with. But as AI is given more responsibility, we need to consider its risks.
AI is a term that is thrown around quite often, but what exactly does it mean? AI is an algorithm capable of learning and making decisions on its own, given a constant stream of data. Machine learning, or ML for short, is a subset of AI. ML finds patterns in data that AI uses to make decisions. It's also important to note that AI is iterative, meaning it's constantly trying to improve its accuracy as it encounters new sets of data.
Some prominent examples of AI include Alexa and Siri. They continue to improve their natural language processing abilities to provide more accurate answers to the questions we ask. Nevertheless, AI has taken the world by storm. But since AI and ML's advent, serious concerns have arisen over how to protect AI from potential cyber attacks.
This new cybersecurity dilemma is due to the black box phenomena. AI is given a set of inputs and outputs and asked to make decisions based on this data. But how the machine learning algorithm finds patterns in this data is not entirely known to the developer. Its decision-making process is hidden from view, hence the phrase black box.
The notion of a black box has existed from the beginnings of the tech industry and exists in non-technical settings as well. Not all employees of Google know how Google's search engine works, nor does a cashier at ShopRite know when the next shipment of bread will come in. However, humans can communicate between sectors in order to turn a black box into a glass box.
But AI cannot communicate in the same way that humans can. And this is where AI goes wrong. Oftentimes, an AI model will pass developer testing with an acceptable range of accuracy, but the developer may not be aware of some hidden associations within the test data that the AI model relies on to make its predictions.
When the model is deployed and the data it encounters in real time does not have the same patterns, all of its prior training goes out the window. From different background colors to inconsistent formatting, factors we may consider inconsequential can radically alter an AI's outputs.
And depending on the use cases for these models, the inaccuracies can be fatal. Joshua Brown used Tesla's autopilot feature on local roads, even though it was designed for use on highways. The car saw a truck coming from the side, and instead of braking, it kept going. The passenger ended up dying.
The autopilot feature was certainly trained to recognize trucks, but only the backside. When it saw the right side of the truck, it confused it for a road sign and decided it was safe to proceed. And this wasn't the first time. Similar instances took place in 2019 and 2020.
Tesla uses convolutional neural networks, a branch of deep learning, to process the images a car sees. In CNNs, the images a car sees becomes the input for the model. The algorithm will then break down the image into individual pixels and run it through a filter to identify characteristics, edges, shapes, etc. The model tweaks the weightages of different filters to be able to identify the image in its entirety.
To us, some defining characteristics of a car may be its wheels or body. But since we do not know the weightages the model uses, we also do not know which features are more influential in determining the model's output.
And it's deep learning that companies are using for their AI solutions given its capabilities compared to standard models. It's also deep learning that is the least interpretable. This opacity has created a new branch of cybersecurity threats, all aimed at exploiting the shortcomings of AI. We'll be tackling this problem in our next video. Thanks for watching.